Welcome to another episode of The Next Prompt. This is Pandurang Kamat, and I have with me Rajesh Abhyankar. Happy to bring insights from Suzega's journey week over week, month over month. In January, we spoke to you about how software engineering jumped onto a next S-curve. We talked about how models had improved in terms of writing code so much that we could rely a lot more on them, orchestrate them to write code not just for small modules and tasks, but long-running complete features that can be written more effectively. This episode, we will dive into how Suzega has evolved, how our platform for delivering software, that is Ithara, has evolved in the last 2 months with this new S-curve, and how we are bringing that value to clients. Back in January, we talked about the major shift in software engineering that took place, sometime starting late 2025 with the advent of new version of Claude Code and the better models that came out. And Rajesh and I talked about how that changes the way we build software. And two fundamental things that happened there was not only did the models get so much better at coding that we could rely on them to reason through more complex code and write better and structured code of higher quality, we started capturing more of our insights into the agent skill into markdown files that were loaded progressively and gave that intelligence to the agent. Rather than writing complex programs ourselves to orchestrate the agents, we relied more on the model to orchestrate the end-to-end process and building more of the intelligence in the skills and the markdown files. So that shift clicked something within Suzega and the way we worked with clients. So Rajesh, why don't we start there on what exactly changed in our approach and the way we built Ithara to deliver software faster to clients?
If you ask anyone how to define an agent, and you will get a different answer from everyone. But in fairness to them, it's because the paradigm itself is changing. Instead of having an agent for every single business process or your software engineering lifecycle, what's emerging now is the core agentic loop, which is pretty much the standard. And the skills are the ones that you write many of them. And then the agentic loop decides based on the user's question on which are the relevant skills. Maybe skills are the new microservices as a mental model. For those who have been thinking about decomposing a monolith application into microservices, it seems pretty similar now that your skills are more discrete and you can decompose them, test them really well. They can represent uniqueness about your company, your domain knowledge, your business process. And we applied that not only for business, but then we started applying that to software engineering. And that is what completely changed the trajectory of how Ithara was built. We pretty much rewrote the core 6 months into the process. And it's quite exciting now where we are headed and how it's making our teams more productive.
Absolutely. And this is where we want to bring in one of the very important aspects of, how it is shifting the way enterprises write code. This is not about wipe coding, and this is not about one-shotting something that will run forever in the enterprise. This is about bringing the foundations of software engineering that we have been working on and perfecting as an industry for multiple decades, and combining that with the way AI is able to build software so that we get the speed that AI brings, but also the rigor, the predictability, the quality, and the security that software engineering as rigorous science brings to this field. So let's talk about what it meant for Ithara. And today, as we think about pivoting, and we are already at a new version of Ithara, which is allowing us to deliver software even faster and even of higher quality, how did Ithara itself evolve, combining this software engineering and AI together?
Yeah, the core thesis really is, look, agent-generated code is easy. Right? Anyone now with Cloud Code or one of the coding agents can quite easily write a few lines and generate some code. Right? That's the easy part. But to make something that is enterprise quality, enterprise grade, that's the hardest problem. And right now, everyone, the industry seems to be drunk on the velocity, and there's a lot of anecdotal evidence on the collapse of the quality happening right underneath. I was reading some reports about how most of the AI-generated code on GitHub tends to get only 2 stars. I haven't dug detail into it, but we know it firsthand that like simple things like Claude code, what our engineers tell us is it likes to write a lot of good data model and API. It forgets to write UX. UX is pretty much like an afterthought with no user interface. As long as the feature is built in an API, it tests it and it's done. Now, what about the user interface? We have to put controls on it. That's just a small example of
And sometimes
how
it writes the UI but doesn't connect it effectively with the backend.
sometimes it does that, yeah, in hard code that. So it may feel that we are moving fast, but we took a step back, and the real insight, which may not be that surprising to many who've been in the field for a long time, the real insight was we've had all the best practices for a long time, like almost 30 years. We need to dust our shelves and get those best practices out that have been sitting there for 30 years. Right? We called it software engineering when it was not quite engineering at that time, but it has evolved. There's a body of knowledge. There, people have captured a lot of hard lessons learned into a process. So our insight here really was the agents can write code really fast. That's great. Let's cover the upstream and the downstream. How precisely can we write the spec? And we know that right? If you can't specify what you want, no agent, no matter how smart, is going to be able to build it right. In our case, we provide applied AI services and innovation services to our clients. And unless we go deep into understanding the client's domain, understanding their real pain areas, capturing them precisely. So a lot of the hard thinking has moved upstream for us, which is a good thing that we are now spending more time. But then the downstream is a good old practice of defect removal efficiency. There were many metrics like those that we used to have 20, 30 years ago. We may have to bring those back because the speed with which you write code, if you can write or agents can write code at such high speed, then it's quite obvious that defects also are likely getting introduced at the same high speed. Yeah. What about defects? You can't just ship that. And we have some best practices. We know unit testing, we know test-driven testing. So with Ithara, we were experimenting with all of those. It's less about which model and how fast and how can we do sub-agents and parallel agents and so on, right? What really matters is, did we provide the right and precise specifications? And do we have enough controls in place to detect all kinds of defects that might have gone into it? And can we catch it? So our big insight, and one of the ironies of all of this, is the best and the greatest technology that computer scientists have, or our industry has built, which is the computer programs can now write code of high quality at high speed. But we went back to the terminal where everything started, right? Those who've been in the Unix and the wax days and so on, you know what the terminal was. A lot of the new generation, I explain to them, when you say terminal, do you know what it is? It's actually a simulation of the hardware. There used to be a terminal, a keyboard attached to it. And now when you open a terminal, it's simulating that hardware terminal. And a lot of the shell commands, the bash commands, they're not commands, those are shells and those are concepts that, so there's a lot of legacy that we are riding on. And it's good to see all of that coming back, that a lot of the agentic coding is happening in the shell, in the command prompt. And the best tool that Claude Code uses is Bash. Who would have thought that the most cutting edge technology meets the 70s and 80s technology of shells? So what we are hard at working is less around how do we get the best agentic harness and so on. That's happening naturally. We're adopting it. When skills came along, you can't ignore it. You have to adopt it because it makes sense. It makes you more productive. But where our attention is going in right now is running a lot of experiments. If test-driven development is so good, can we write all code by test-driven development? Can we capture all the specifications and convert them to tests, and the AI only writes code that adheres to those tests? What about integration testing? What about an integration not just within the repository, but also all the external interfaces? Many times you don't have access to all of those. So do we build the stubs there for replacing or as a stand-in for the CRM and the ERP and all the backend systems that the client might have? And how do we do black box testing and smoke testing? And there's a whole bunch of techniques that have been around for a while. But I think on the similar lines, you need to bring back the good old software engineering practices to build enterprise class quality. So it's really not, in our AI services, it's not so much about the model. It's about the engineering that we build around that model. The question is, would you bet your production system on that style of working, or spend 5 minutes in writing the code, but then you're spending 50 minutes ensuring it's enterprise quality. It adheres to the architectural principles. It's following your coding standards, and you have enough tests in place. There used to be a whole concept of traceability. We're bringing that back. Did we code it? Did we unit test it? Did we do the integration test? Did somebody finally go and do a system or the end-to-end test, only then certify? And there are a lot of human reviews along the way. There's adversarial reviews, like one AI writes the code, the other AI reviews it and tests it and so on.
That's a great overview of how Ithara itself has evolved. But as we were building Ithara, we also realized that despite the evolution of the models in writing better code and writing code for longer time without deviating, there is still a lot of experiments that you did to right size what are the bite-sized tasks that a model can complete in a finite amount of time without creating errors or distracting from the primary path and so forth. Tell us a bit more about how does a Suzega developer and development team today interact with Ithara in that cycle of going from spec to tasks and adversarial reviews. In human engineering teams, the review used to be done with a team or member or members who were not part of the team that developed that feature. And we are doing kind of similar thing with models now, that the model that developed the code has to pass the test with critical reviews from alternate models. And so how is that baked into Ithara, and how is that improving the quality overall?
We have to make it frictionless. You can't put a lot of ceremony around where I go to this site and get approvals and set up some console and then download something, and you've already lost them. They would rather go and get some plugins that are so easy from the cloud marketplace, for example. So the first step was to make Ithara so easy to use that it should just be at your command prompt. It can help you write everything. As you know, our engagement model is very different. We call it innovation streaming, which is developing production quality software in 6-week cycles. And then we take 2 weeks to deliver. So it's about 2 months at the time. So we get 6 such cycles in a year. So that rhythm is what a lot of our mid-market clients really appreciate, because these are not 6-month and 9-month transformations. You see something in production every 2 months. And in order to do that, the speed with which agent can write code is helping us get there. But the rest of the harness that we've had to put in place and continue to innovate and make it easy for our engineers to adopt it. So let's say an agent that does all of my accounts payable processing, that one line doesn't work, right? You need to break it down. But you don't want to write a 1,000-line spec either and give one monolith, because somewhere in the middle, we know the context is lost. So we experimented with what's the right size. And we figured out that there is a certain size with which we can break. So there are skills now that are consistently being followed across all of our delivery teams, so that no matter who's delivering it, there's a standard way in which we deliver. And reminds me a lot of these automated cars, right? One car learns something, it's adopted into the skill set, and then suddenly all cars become smart. So if one project discovers something, there's a mechanism by which we are now able to share it with all of our delivery teams. And so the frictionless, the compounding effect of learning from each other, improving our processes, and bringing in the old techniques of test-driven development, spec-driven adversarial reviews. And when we break all these requirements into the right size chunk, we are now experimenting with, now can we go a one-shot way where there is a whole method and flow built into it. We think that as the models are improving and as our process increases, that we'll get there. But yeah, the bottom line is, while everyone is celebrating that agents can write code, which is great. But what we are asking is, does that code deserve to be in production? And how can we make it production ready? And then stand by it. We've built pretty sophisticated harnesses now that as the code is being written, we can detect the defects, we store them, and we look at how fast did we catch them, and then try to create our own baseline. It's less about just the way we write the code, but how do we bring in the software engineering discipline, which we thought was obsolete, but really that's the only thing that's standing behind AI-generated code and enterprise chaos. That's what we are after, doing it in a very thoughtful way.
Absolutely. And I want to double click on that defect removal part a little bit, right? Because one of the fundamental benefits that AI brings to us, if you use it right, is the ability for any system to learn over time and hopefully not to repeat the same mistakes. But this doesn't always come automatically, right? And that's where Ithara has this learning loop, hopefully not repeating that defect or a similar kind of defect in a different circumstance. And that's the knowledge that compounds across projects. So it gets better over time. Anything you want to add to, why that matters and how really we tackle that problem?
I like to say that everyone's talking about building agents and co-pilots. And if you extend the same analogy, it's not really co-pilots. What you need really is a whole flight manual, because now there's a new way in which you can move fast. But our differentiation or our competitiveness is the method that we follow and the governance that we put in place around these agents on how we build things. We are shrinking those 6-week cycles down to even 2 weeks or 3 weeks now, and then we take that additional time to spend more time with the client. But if you really bring it down, it's simple common sense. It just says that have clarity in what your clients want, document it, make it the right size so that the AI agents can digest it in a very precise way. By learning all of those and having a mechanism by which you feed all of that to remind the agent saying, hey, look, you forget these things. What we mean by something when we say in this domain or in this context and so on. So a lot of that knowledge is being captured. Then there are so many gates that have been put in place to make sure that everything passes through all of those gates. But the PR, again, going back to first principles, the PR thing has come in from the open source world, where you were working with anyone in the world who can just take a copy of your code and they can make some changes to it and they submit a pull request. And you as a maintainer then decide if you review it and if you think it's worth adding to the code base, you merge it.
Yeah.
And that for some reason has become a standard for everyone. And it says, no, AI agent can't just write something and then unit test and then create a PR in an automated way. And then you spend hours and hours reviewing that PR. So for us, PR is more of a signature. Our engineers and our teams, when they have written their code, they have tested it, they have reviewed it, and they've integrated it, then you create the PR. And then you're saying, now my feature is ready to be integrated, and you can still put a few more tests around it, but everything has been done. So we've kind of shifted or changed the way even the current flow works. It's about how many PRs that I found worthy to put my signature on it, saying, I wrote it with the AI agents, with all the software engineering, and with all the Ithara foundation on it. So I think that's where we are headed.
Yeah, that's important. The last insight I wanted to touch upon is we've talked about traceability and verifiability, right? So let's talk a little bit about what that means and how does one objectively verify certain things have been done, whether it's on the back end or front end. How does Ithara help us achieve better software with the traceability and verifiability it brings?
Actually, traceability runs across all the stages of what we do in Ithara. So it's pretty much an audit system for us on every step of the way, whether it's the human part of the process, the agent part of the process. All of that is being traced all the way back to what did the client ask in this engagement. If they ask to build a certain feature, it ties all the way back to a business use case, a business feature, a functional requirement in the old terminology, or a non-functional requirement. So everything has to tie back to that. Think of traceability as a string that attaches throughout the process. If I pick one functional requirement, I should be able to explain and prove everything that got generated as a result. What was the architectural decision that was made to implement this requirement? How did it get decomposed into a data model or a user interface or an agentic interface? It could be a migration and modernization example. So in that case, it's data lineage, that where did this data field come from? If you are modernizing it, we need to trace every single data field all the way back to the source systems and so on. So it depends on the nature of the engagement. The next step on the traceability is, okay, we understood it, we did the specification, we did the coding, now how did we test it? And there are 3 ways to test it. And trace it all the way back to where are those regression test cases sitting that were run to make sure that by implementing this, nothing else broke. And then the human verification that happened in between. Because of this beautiful traceability that we already built, we can jump straight in and said, oh, I can see why this defect got injected and trace all the way to how we could have caught it early on. So traceability runs all across, and to us that's more like the audit trail of everything that happened in the system. Even when the agent is running, we have enough hooks in place and everything is being recorded. So we are not just running agent in the vacuum. So hopefully, I think as part of our discussion today, it became very clear that while the AI is new, the problem isn't. And the software engineering discipline that we thought was obsolete is something that we need to bring back. That's what Ithara is all about. There's cutting edge AI built into it, the latest and greatest thinking and the models and the way we run the pipeline, either on the developer's machine or completely autonomously in the cloud. We have all of those options available, whatever the engineer decides. So you have a whole spectrum of flexibility. It's frictionless for people to use it, and the good old software engineering practices built into it. Right? That's pretty much the secret sauce that we are revealing on what Ithara does.
Absolutely. And this is changing the way our engineers at Suzega perform their function on a day-to-day basis, right? They've had to shift their focus on thinking about the business problem in much more depth, expressing that in a very concise, articulate, and yet unambiguous way, so that the AI tools that we build can actually execute the process for them. So engineering as a profession is shifting the way people do their jobs. And this has not been an overnight shift for us at Suzega. It took us a while to get people to think more like this, they are more of an orchestrator of an army of AI agents that are building software rather than coders as they used to think of themselves when they used to write code even a couple of years ago. And that's, I think, every organization, it's important for them to learn. So to recap, we are telling the world that, hey, you can have your speed and quality too. And in the age of AI, software engineering still exists as an art and a science. And software engineering paired with AI can actually deliver more robust, more resilient, more manageable enterprise-grade software, and not just having looked at it as wipe coding, right? When you think of it as holistically, it does a much better job at it. Any final thoughts, what you want to let clients know when they're looking at all of this AI revolution happening and how Suzega brings it to their enterprise?
The client conversations we have is, if AI can do this really fast, I just prototyped something last night on my iPad. And here you go, right? This is the feature that I built. And the next question I ask is, are you comfortable putting it in production? We can take whatever you built and we'll put it in production. And then nobody wants to do that. So the takeaway really is, the best agent is not the one that writes the most amount of code or the fastest amount of code, but we evaluate our entire delivery practice is agents that we use are the ones that write the least amount of code that passes the most tests. Capture that in a nutshell. That we are flipping the story here. We are not saying the code generation, if it's a solved problem, then the code governance is still not solved. And that's what we're trying to solve with Ithara.
Very well put. So there you have it, folks. Don't forget to subscribe. We are on Spotify, Apple Podcasts, and every other place where you listen to your podcasts, YouTube as well. And let us know your thoughts, because that always drives us into improving what we bring to you. Until next time, this is goodbye from Rajesh and Pandurang.